Okay, let's just look at an example. It's easier for me to explain what to do when you can actually see what you're supposed to do. So you are, for these problems, finding the indicated angle measure to the nearest tenth, so 1 decimal place. So this one wants us to find the measure of angle A. So again, I'm just going to put a little marking here by angle A because that's the angle that I'm using. What you want to identify is, notice I'm given 2 side lengths. Identify if those are opposite, adjacent, or hypotenuse. So the 18, is that opposite, adjacent, or hypotenuse? This is opposite the angle. What about the 27? That's the hypotenuse. So now think of SOHCAHTOA. Which one, sine, cosine, or tangent, uses opposite and hypotenuse? Yeah, the S, opposite over hypotenuse, is sine. So I will have, this is how it's going to be set up. I'm going to say sine of angle A, which I don't know what it is. So sine of angle A is equal to, and then I have opposite over hypotenuse. So 18 over 27. Okay, so normally what you had yesterday, you probably would have just typed something in here to find this. This is what's happening. So I'm going to use a different color to show this. When you have sine of A, to solve for A, you cannot divide by SIN. SIN means nothing by itself. It's sine of the angle. The angle is attached to it. To cancel this out, I have to take the inverse sine of it. So if you want to see me write this and then write it on your sheets. So I am actually taking inverse sine of both sides is what's happening. I just didn't want to squeeze it enough here, so I rewrote it down here. So it's kind of like when you take the square root of each side, you say it like that, I took the square root of each side. This is taking the inverse of sine of both sides. So I'm not multiplying by inverse sine, you're taking inverse sine of both sides. So what happens, inverse sine and sine, they're inverses, they cancel each other out, so you're just left with A. This you type in your calculator. So I would go, I'm going to retype this in. So if I want the inverse of sine, I have to do second sine. And then notice the parenthesis comes up. So in those parentheses, I can type in 18 divided by 27, and then put the right parenthesis to close it, and hit enter. And this answer is an angle. So the direction set to round to the nearest tenth. So this would be approximately 41.8 degrees. So measure of angle A is 41.8 degrees. In your work, I'm not going to require that you show this step every time. So as long as you know that if you have this written, that to find A, you have to do this step here, take the inverse sine of the other side. I just wanted to show you why you're doing that. I know it's explained up here. This is kind of the why. You're canceling out the sine. So let's go through another one. Let's go through number 2. We're finding the measure of angle B. So I'm going to mark it. Look at the 2 side lengths you have and label them. So what would the 6 be? Opposite, adjacent, or hypotenuse? 6 is the adjacent side. What about the 20? 20 is the opposite. So am I using sine, cosine, or tangent? Tangent, yes. I have O over A, opposite over adjacent is tangent. So I would set it up this way. Tangent of angle B is equal to, the opposite is 20 over the adjacent is 6. Okay, I'm not going to show this middle step for this one, so I'm going to show you what I would like to see on yours. So therefore, if I want to find B, I then have to take the inverse of tangent of the 20 divided by 6. Okay, because again, I'm really taking inverse tangent of both sides, which is canceling out the I do second tangent of 20 divided by 6, close the parentheses, hit enter, and it should be approximately 73.3 degrees. Any questions on those two so far? Okay, I want you to do number 3 then. Find the measure of angle A for that triangle. Help each other out. I'll walk around in a moment to see if there's questions, or if you have questions on your calculator, now would be a great time to ask. All right, looks like we're okay on these. Double check, some of you had it set up, but didn't quite have it calculated yet, so make sure you also can calculate it the right way. All right. Then for the last set of examples, this is where we are combining the 2 days. So ultimately, if you are asked to solve a triangle, specifically we're working with right triangles. When you are asked to solve a right triangle, this means you find all of the angle measures and all of the side measures or side lengths of a right triangle. So you're finding everything that is missing, as well as labeling what's given to you. Right, I need your attention up here, please. So notice I have it laid out on here right now. That means you're finding 6 things. There's 6 answers to one of these problems because every triangle has 3 angles and 3 side lengths. So some of this is already given to you. So angles, we're going to be trying to find the measure of angle x. We are also going to be finding the measure of angle y and the measure of angle z. We already know the measure of angle z is what? Z is 90 degrees. Yes. X and Y, you don't know. You're not expected to guess. We're going to use trig functions to find them. Then, side XZ is 5. That is given. The other 2 sides, we also have side YZ and we have side XY. All right, we also know what side you could have called this ZY as well, or YX. The order doesn't matter. But YZ, that side length, we also know is 9. So we're given 3 things. We're given 2 sides and 1 angle. We need to find the other missing 3. I would start, if you know 2 side lengths of a right triangle, you can find the third. How could we find the third side? Think about what we've covered in this chapter so far. If you have a right triangle, what could you use to find the missing side? That would only be if we knew this was a 30, 60, 90. Nope, that's okay. You're thinking, though, that we could use that. What was the first thing we covered in chapter 8, aside from simplifying? Pythagorean theorem. Do not forget about the Pythagorean theorem. All right, if you know 2 sides of a right triangle, you can find the missing side using the Pythagorean theorem. So let's just say I'm going to call this C because it's the hypotenuse. I want to set it equal to something. So I would say 5 squared plus 9 squared equals C squared equals my hypotenuse squared. Solve for C. So I know 5 squared is 25 plus 9 squared is 81. 25 plus 81 is 106. And then I can solve for C by taking the square root of both sides. And let me see here. I'm going to see what it says on the assignment so I can be. Those are all angles. Let's just, for these directions, it doesn't quite say. I'm going to say for these, because we're going to be rounding angles as well, round everything to 1 decimal place for right now. So I'm going to type in the square root of 106. All right, so that side is approximately 10.3. Okay, and that was side, I labeled it C, that was side XY. So the missing side is approximately 10.3. All right, then I have to find 2 angle measures. So let's just start with X. Let's find X first. All right, and look at what you're given. So I'm not even writing what C is here. I'm going to look at what I'm given. Look at those 2 sides and label them again. Opposite, adjacent, hypotenuse. Yes. It'll be tangent. Yeah, 9 is opposite to angle X, and then 5 is adjacent to angle X. So just like you just had in the previous examples, I would say tangent of X is equal to opposite is 9 over adjacent is 5. And then that would mean X is equal to the inverse tangent of 9 over 5. So inverse tangent of 9 divided by 5 is equal to approximately 60.9 degrees. I rounded to just one decimal place. Yeah. I know it doesn't say in these directions. Your assignment specifies where to round to. It's either 1 or 2 decimal places. Then we could do something to find, or something similar to find angle y. However, we haven't formally talked about it in here. You may know this already from previous math classes. Anybody know what the angles in a triangle should add up to be? 180. So rather than setting up another equation like this, I can find the measure of angle y by taking, so I'm going to write it this way, measure of angle y will equal 180 minus my other two angles. So minus 90 minus 60.9. That means measure of angle y is approximately 29.1. So there's a lot of problem solving that goes into solving a right triangle and really thinking about, based on what I'm given, what methods have I learned that I can use to find what's missing. So there's not even one specifically right way to work through it. I would definitely find this side first. I could have found angle y first and then angle x. Any questions on example 4? Okay, 5 is a little bit different because you're given different pieces of information. So I also want to look at 5, and then you'll have time to work. So again, I'm going to fill in what we're all trying to find. So we're trying to find the 3 angles, measure of angle P, measure of angle Q, and measure of angle R. And then our 3 sides, we have PQ, we have QR, and we have PR. And now I'm going to fill in what I know. So I know the measure of angle Q, that's my 90-degree angle. I also know the measure of angle R, that's given as 33 degrees. And then I know side PQ has a length of 16. What could we find first here? Angela? Angle P. How do we find angle P? Yes, I have 2 angles, so I can find my third one by subtracting the other 2 from 180. So 180 minus 90 minus 33 means angle P is 57 degrees. Okay, now I have 2 side lengths to find. So this one's a little different because I cannot use Pythagorean theorem because I only know one side. You have to know 2 sides to use Pythagorean theorem. So instead, this is where you're going to use a trig function like we did yesterday. So you're still using these. So let's say I want to find this side first, QR. So I'm going to call that X for right now. All right, so I have my angle of 33 degrees. Label the 16 and the X as opposite, adjacent, or hypotenuse. So what is the X? X is adjacent. What is 16? Opposite. So which trig function, sine, cosine, tangent, am I going to use? Tangent, because I have opposite and adjacent. I have O and I have A. So I would say tangent of, I know my angle is 33, equals the opposite is 16 over the adjacent. I'm calling X for right now. And I solve this for X. Careful how you solve this for X. I do not multiply or divide both sides by 16. I need to get X out of the denominator. Multiply both sides by X. So that I have X times tangent of 33, equals 16. And then, because I'm multiplying x by tangent of 33, I can divide by tangent of 33 on both sides. So you're really typing into your calculator 16 divided by tangent, I don't hit second, I'm not finding an angle, tangent of 33, close the parentheses, enter. So that's approximately 24.6. And that's, I called it X, that was QR, 24.6. Okay, now, again, I really am going to stress whenever you're finding something that's missing, you should only use the given information. You shouldn't now use a value you found to plug in. So I still, even though I now know two sides, I still wouldn't use Pythagorean theorem. I would call the other missing side a different variable. I'll call it y. And I would use a different trig function to find y. So y is my hypotenuse. So I'm going to cover up the x. If I know the opposite and I'm trying to find the hypotenuse, opposite and hypotenuse, which trig function am I using? Sine. So I would say sine of 33 degrees equals opposite over hypotenuse, so 16 over y. And then I have to solve this very similar to what I did for x. I need to multiply both sides by y. So y times sine of 33 equals 16, and then divide by sine of 33. So 16 divided by sine of 33 equals approximately 29.6.